Every year, Belgian farmers pull 30 tons of metal from their fields: rusted shells, corroded grenades, unexploded chemical weapons from a war that ended over a century ago. They call it the Iron Harvest. Some of these devices still detonate. In 2014, two construction workers died near Ypres when their excavator struck a British gas shell from 1917. The war isn't over. It just stopped shooting. But here's what the statistics don't tell you. Artillery caused roughly 70% of all casualties in World War I. Not machine guns, not gas attacks, artillery. And among the weapons that filled those trenches with corpses, one stands out not for its technological sophistication, but for its brutal, democratic efficiency and a design flaw that turned it into a lottery of death for everyone involved. The German steel hand granate 24, the stick grenade, killed thousands of Allied soldiers. It also killed hundreds of the men who threw it. The story begins, like most military disasters, with an elegant theory meeting messy reality. Humans have been throwing explosives at each other since the Chinese invented gunpowder. By the 15th century, we'd figured out how to launch those explosives from tubes. For 400 years, the technology barely changed. A cannon fired, recoiled backward several feet, and had to be manually repositioned before firing again. Crews could manage maybe 2 rounds per minute if they were well trained and lucky. Then, in 1897, French engineers solved a problem that had stumped every weapons designer in history. The French 75mm field gun introduced the high-drop pneumatic recoil system, a mechanism so simple in concept and so devastating in application that it redefined what artillery could do. When the gun fired, instead of the entire carriage rolling backward, a piston compressed oil and air in a cylinder beneath the barrel. The barrel recoiled, the fluid absorbed the energy, and springs returned the barrel to exactly its previous position. The gun remained aimed. The crew remained in place. The rate of fire jumped from 2 rounds per minute to 30 shells per minute. The same crew, the same gun, 15 times the killing capacity. Every major power understood what this meant. Germany developed the 77mm field gun. Britain fielded the 18-pounder. Russia copied the French design outright. By 1914, European armies had stockpiled millions of shells and trained hundreds of thousands of artillerists in the new doctrine of rapid fire. Staff officers ran calculations and predicted a short, mobile war. Cavalry would sweep around flanks. Infantry would maneuver in open terrain. Artillery would provide support, suppressing enemy positions while the real soldiers decided the battle with movement and shock. Then the shooting started, and every assumption collapsed within weeks. The German invasion of Belgium should have been a textbook demonstration of modern warfare. German troops advanced on a network of fortresses that the Belgians believed were impregnable. Concrete walls 12 feet thick, surrounded by moats, protected by overlapping fields of fire. The forts had been designed to withstand any field gun in existence. Unfortunately for the Belgians, the Germans didn't bring field guns. They brought Big Bertha, a 420mm siege howitzer that fired shells weighing over a ton. The first fort, Liège, held out for 11 days. When Big Bertha arrived, as anticipated, the battle ended in 2 days. The shells punched through concrete like paper, detonating inside the bunkers, filling the corridors with blast waves that ruptured lungs and collapsed walls. Survivors described the sound as beyond hearing, a physical pressure that made men's ears bleed. The other forts surrendered without waiting for the same treatment, but the real killing began at the Battle of the Frontiers when French infantry, still clinging to the doctrine of offensive à outrance, attack to excess, marched in parade formation directly into German artillery positions. The French believed that morale and élan would overcome firepower. They wore bright blue coats and red trousers because camouflage was considered cowardly. They advanced in dense columns because their doctrine said that was how you concentrated force. On August 22, 1914, the French army lost 27,000 men in a single day. Most of them never saw the enemy. They died in wheat fields and forests, torn apart by shrapnel from guns positioned 3 miles away. The shells arrived without warning, a distant rumble, then a shriek, then an eruption of earth and metal and body parts. Officers who had studied Napoleonic tactics watched their battalions disintegrate in minutes. The wounded crawled into shell craters for cover. The living joined them. By nightfall, both sides had learned the same lesson. If you stayed above ground, artillery would kill you. The only rational response was to dig. Within months, the Western Front had transformed into a line of trenches stretching from the English Channel to Switzerland. And that's when the industrial crisis began. Pre-war planning had been meticulous. Staff officers had calculated ammunition requirements based on historical consumption rates. The German army entered the war with a stockpile designed to last 6 months of intensive fighting. They burned through it in 6 weeks. The French ran out of 75mm shells by October. British factories were producing 500 shells per day when the army needed 50,000. Every nation faced the same problem. Modern artillery consumed ammunition faster than any economy in history could produce it. The solution required a total reorganization of industrial society. Factories that had made farm equipment retooled to manufacture shell casings. Chemical plants shifted from fertilizer to explosives. Governments suspended labor laws, drafted women into munitions work, and ran production lines 24 hours a day. By 1917, Britain was producing over 1 million shells per week. France matched that output. Germany, despite the Allied blockade, managed similar numbers. The Western Front became a machine for converting industrial output into corpses. Raw materials entered factories in London, Paris, and Essen. Shells left by rail traveled to depots, moved to forward magazines, and were fired into the opposing trench system. Then the process repeated. The romantic notion of war as individual combat between brave men was obsolete. This was industrial mathematics: production capacity times logistics, efficiency times rate of fire equals casualties. But industrial production solved only part of the problem. Artillery was useless if you couldn't aim it. The technical challenge was straightforward. How do you hit a target you cannot see? Trenches were dug below ground level. Targets were miles away. Direct observation was impossible. The solution required inventing an entirely new system of intelligence, communication, and calculation. Forward observers positioned themselves in church steeples, ruined buildings, or specially constructed observation posts. They identified targets and relayed coordinates via telephone lines buried 6 feet underground to avoid shell fire. When telephone lines were cut, and they were cut constantly, runners sprinted through artillery barrages carrying handwritten messages. The casualty rate for runners was roughly 30%. They kept running. For targets beyond visual range, both sides deployed observation balloons, hydrogen-filled gas bags tethered 2 miles behind the lines, carrying observers with binoculars and maps. The balloons were enormous, visible for miles, and filled with explosive gas. Fighter pilots hunted them specifically. Observers carried parachutes and jumped when attacked. Many didn't make it. The balloons kept going up. Aircraft added another layer. Reconnaissance planes photographed enemy positions, noting changes in trench layouts, new gun emplacements, and supply dumps. Photo interpreters studied the images, measuring shadows to determine the height of fortifications, counting wagon tracks to estimate troop movements. Counter-battery warfare, the art of locating and destroying enemy artillery before it destroyed yours, became its own specialized discipline. Sound-ranging teams used microphones positioned in a geometric array to triangulate gun positions based on the sound of firing. Flash spotting teams did the same using visual observation. The calculations required trigonometry, compensation for wind and atmospheric pressure, and speed. If you were fast enough, you could drop shells on an enemy battery before it finished its fire mission. War had become an intellectual exercise, and at the center of this vast technical apparatus was the shell itself. Not all shells were created equal. Understanding what killed you required understanding the taxonomy of destruction. High explosive shells, HE rounds, were designed to destroy fortifications and equipment. They contained TNT, amytal, or picric acid packed into a steel casing. On impact, the explosive detonated, fragmenting the casing into thousands of pieces of shrapnel traveling at supersonic speeds. The blast wave alone could kill at 30 feet, rupturing internal organs even if no fragment struck you. HE shells cratered the earth, collapsed bunkers, destroyed wire obstacles, and turned the landscape into a moonscape of overlapping holes. Shrapnel shells were different. They didn't explode on impact. They were designed to detonate in the air above enemy troops, functioning essentially as airborne shotguns. The shell contained hundreds of lead balls suspended in a matrix around a small bursting charge. A timed fuse ignited the charge at a preset altitude, scattering the balls downward in a cone of death. If the fuse was set correctly, a single shrapnel shell could kill or wound every man in a 50-yard radius. If the fuse was set incorrectly, the shell was useless. Artillery crews spent hours adjusting fuse timings based on range, temperature, and wind. The math had to be perfect. Then there were chemical shells, the weapons that no one had wanted and everyone eventually used. Chlorine gas, deployed by the Germans at Ypres in 1915, caused death by drowning as the victim's lungs filled with fluid. Phosgene was more efficient, odorless until it was too late. Mustard gas didn't kill quickly. It blistered skin, blinded, and left survivors with permanent lung damage. Chemical shells mixed the horrors of gas with the reach of artillery. You didn't need wind direction. You didn't need to wait for meteorological conditions. You just fired the shells and let chemistry do the work. Illuminating shells turned night into day, suspended beneath parachutes, burning magnesium to light up no man's land during night raids. Smoke shells created concealment for advancing troops or marked targets for aircraft. Incendiary shells set buildings on fire. The variety was limited only by industrial imagination.